Warsaw, Poland. September 14, 1993. A cold storm front is sweeping across the city. Heavy rain crashes onto the runway, while violent winds keep changing direction every few seconds. Lightning flashes in the distance. Controllers in the tower warn arriving crews about wind shear near the airport. Most aircraft are still landing safely, but one Airbus A320 is about to enter a situation nobody fully understands yet. Inside the cockpit of Lufthansa Flight 2904, two experienced captains focus on the final approach. Both are highly trained professionals flying one of the most technologically advanced passenger aircraft in the world. The Airbus A320 was designed to represent the future of aviation. Computers controlled many of the aircraft's systems. Automation protected pilots from dangerous mistakes. Airbus believed technology could reduce human error and make flying safer than ever before. But on this night, those same protections would trap the crew in a disaster they could not escape. The airplane will touch down on the runway. The pilots will command maximum braking, and absolutely nothing will happen. For 9 terrifying seconds, the aircraft will continue racing forward through heavy rain with almost no braking at all. By the time the systems finally respond, it will already be too late. Moments later, the Airbus will leave the runway at high speed, crash into an embankment, burst into flames, and become one of the most controversial accidents of the early Airbus era. Tonight, we're looking at the tragic story of Lufthansa Flight 2904, a crash where weather, automation, and human decision-making combined into a catastrophe nobody expected. To understand why Flight 2904 became so important, we first need to understand the aircraft itself. In the late 1980s and early 1990s, the Airbus A320 represented a revolution in commercial aviation. Compared to older aircraft, the A320 looked futuristic. It featured digital fly-by-wire controls instead of traditional mechanical systems. Instead of pilots physically moving cables and hydraulic controls connected to the wings, computers interpreted pilot inputs and adjusted the aircraft electronically. The airplane also introduced advanced protections designed to prevent dangerous maneuvers. Airbus engineers believed computers could help eliminate many of the errors that caused aviation accidents. To airlines like Lufthansa, the A320 symbolized modernization and safety, and Lufthansa was one of the first major airlines to fully embrace this new technology. By 1993, the airline operated one of the most advanced fleets in Europe. But there was still one problem. Pilots around the world were still learning how these new automated systems behaved under unusual circumstances. And on Flight 2904, that learning process would become deadly. On September 14, 1993, Lufthansa Flight 2904 prepared for departure from Frankfurt Airport in Germany. The destination was Warsaw-Okęcie Airport in Poland, now known as Chopin Airport. The aircraft operating the flight was an Airbus A320-211 registered D-AIPN. Inside the cockpit sat 2 experienced Lufthansa captains. The pilot flying the aircraft was completing a check flight after not flying for roughly 90 days. He had more than 12,700 total flight hours, though only around 100 hours on the Airbus A320. In the right seat sat the instructor captain supervising the flight. He had over 11,000 flight hours and extensive experience. The rest of the crew included 4 flight attendants. There were also 64 passengers on board. In total, 70 people were on the aircraft. At 4:47 p.m. local time, the Airbus taxied out normally. The weather in Frankfurt was manageable. Nothing about the departure suggested the crew would soon face one of the most difficult situations imaginable. After takeoff, Flight 2904 climbed smoothly and headed east toward Poland. The flight itself was routine. Passengers relaxed in the cabin while the Airbus cruised efficiently through European airspace. Inside the cockpit, the atmosphere remained calm and professional. The pilots monitored systems, reviewed approach information, and discussed the deteriorating weather ahead. As the aircraft neared Poland, the crew began receiving ATIS weather broadcasts from Warsaw. The reports warned about heavy showers, unstable winds, possible thunderstorms, and wind shear near the airport. A cold front was slowly moving across the region. On the aircraft's weather radar, the crew could clearly see dangerous rain cells approaching Warsaw. Still, conditions did not yet appear extreme enough to require diversion. Aircraft ahead of them were continuing to land. So the Lufthansa crew prepared for the ILS approach to runway 11. As the Airbus descended toward Warsaw, the weather intensified rapidly. Rain became heavier. Visibility decreased. Winds shifted constantly. Controllers warned the crew multiple times about wind shear reports from other aircraft. Wind shear is one of the most dangerous weather conditions pilots can face during takeoff or landing. It occurs when wind speed or direction changes suddenly, potentially causing an aircraft to rapidly lose lift. To counter this risk, Airbus procedures recommended increasing approach speed during wind shear conditions. That's exactly what the crew did. And according to the manuals, it was the correct decision. But there was a hidden danger. Higher speed meant the aircraft would carry far more kinetic energy during landing. Under normal conditions, that extra speed could be managed safely. But tonight, the runway was covered in water, and the winds were no longer behaving predictably. The Airbus intercepted the ILS approach to runway 11. The pilots lowered the landing gear. Flaps extended gradually. Flaps 2, flaps 3, then full flaps. The aircraft was fully configured for landing. Inside the cockpit, workload increased rapidly. The pilots noticed they were slightly above the glide slope and descending faster than ideal. One of them commented on the descent rate, 1,100 feet per minute. That was high for a stabilized approach. Outside, rain hammered the windshield so heavily that visibility became difficult. The aircraft also began experiencing constant yawing and rolling caused by shifting winds. Then came another warning. A recently landed aircraft reported severe wind shear near the end of the runway. At almost the same moment, the Lufthansa crew realized something alarming. The wind had shifted behind them. They now had a tailwind. That meant the aircraft's ground speed was significantly higher than expected. The airplane was moving faster over the runway than the crew realized, but by now the runway was visible, and the approach continued. At 50 feet above the runway, the Airbus automatic systems reduced engine thrust to idle. The aircraft crossed the runway threshold too fast. Instead of settling firmly onto the runway, the airplane floated. It continued flying just above the surface while rapidly eating up precious runway distance. The pilots attempted to settle the aircraft down. Finally, the right main landing gear slammed onto the runway first. But the touchdown was uneven. The left main landing gear remained partially airborne. The aircraft tilted slightly. Inside the cockpit, the pilots believed they had landed. The captain immediately called for braking. Maximum braking. But nothing happened. No spoilers deployed. No reverse thrust activated. No meaningful braking occurred. The Airbus continued racing down the wet runway almost uncontrollably. At first, the pilots didn't understand why. The Airbus A320's systems had been designed with safety in mind. The aircraft would only deploy spoilers and reverse thrust if both main landing gear struts compressed simultaneously. This prevented accidental deployment while airborne. In theory, it was a smart protection system. But Flight 2904 had created conditions the designers never fully anticipated. Because only the right landing gear initially touched down, the aircraft's computers still believed the airplane was flying. So the braking systems remained locked. The pilots had no way to override them immediately. For 9 horrifying seconds, the Airbus continued hydroplaning across the rain-soaked runway at high speed. 9 seconds may not sound long, but at landing speed, an airliner covers enormous distances in that time, and every second meant less runway remaining. The rainwater on the runway created another deadly problem: aquaplaning. When enough water builds up beneath aircraft tires, the wheels lose proper contact with the runway surface. Instead of gripping the pavement, the tires begin sliding across a thin layer of water. That dramatically reduces braking effectiveness. Even after the left landing gear finally compressed and the Airbus systems activated, the aircraft still struggled to slow down. At last, the spoilers deployed, reverse thrust activated, and the brakes engaged. But the aircraft had already consumed far too much runway. The remaining distance was nowhere near enough. Inside the cockpit, panic replaced routine procedure. The pilots could now see the end of the runway rushing toward them. One pilot asked desperately, "What do we do now?" The instructor captain replied, "There's nothing we can do." The Airbus continued sliding forward through the heavy rain. The captain attempted steering the aircraft to the right to avoid obstacles ahead. But at approximately 72 knots, around 133 kilometers per hour, the A320 left the runway. The aircraft skidded violently across wet grass. Then disaster struck. The left wing slammed into an embankment and struck an antenna installation. The impact ruptured the wing structure and fuel tanks. Fuel exploded into flames instantly. Fire spread rapidly along the aircraft's left side. Inside the cabin, thick black smoke began filling the interior almost immediately. Passengers screamed as the aircraft finally came to a stop surrounded by flames. What happened next was pure chaos, the cabin rapidly filled with smoke. Visibility collapsed. Passengers struggled to breathe while trying to find exits. Cabin crew members shouted commands and opened emergency doors as flames spread closer to the fuselage. Some passengers escaped through thick smoke and fire. Others became trapped temporarily by confusion and panic. Despite the horrifying conditions, many people survived thanks to the quick actions of the crew and passengers. In total, 63 people escaped alive, but not everyone made it out. One passenger died from smoke inhalation. The instructor captain suffered fatal injuries during the crash. Many others were seriously injured. What should have been a routine European flight had turned into a deadly disaster in just seconds. The investigation. The investigation into Flight 2904 became one of the most important Airbus investigations ever conducted. Investigators analyzed flight data recorders, cockpit voice recordings, weather reports, runway conditions, tire marks, and aircraft systems logic. And what they found shocked the aviation world. The aircraft itself had functioned almost exactly as designed. There was no engine failure, no major mechanical malfunction, no reckless behavior from the pilots. Instead, investigators discovered a chain of perfectly understandable decisions that combined into catastrophe. The weather reports given to the crew had failed to fully communicate the strength of the tailwind during final approach. Believing they mainly faced crosswind and wind shear, the crew followed Airbus procedures and increased their approach speed. That increased landing energy dramatically. Then the aircraft floated during landing because of excess speed and changing winds. The uneven touchdown prevented the braking systems from activating. The wet runway caused hydroplaning, and 9 critical seconds were lost before full braking became available. Those 9 seconds made survival impossible for the aircraft. Flight 2904 sparked intense debate throughout aviation. Many pilots criticized Airbus automation philosophy after the crash. They argued the aircraft should have allowed pilots more direct control during emergencies. Others defended the system, saying it technically behaved correctly according to its design. But the accident proved something important. Automation can create dangerous situations if pilots don't fully understand how systems behave under unusual conditions. The A320 wasn't wrong. The pilots weren't reckless. But the interaction between weather, automation, and timing created a situation nobody could recover from. Following the accident, Airbus reviewed the braking activation logic on the A320. Training procedures for wet runway operations and unstable weather approaches were strengthened. Airlines also placed far greater emphasis on calculating actual stopping distances during contaminated runway conditions. Pilots learned to more aggressively reassess whether an approach should continue when weather conditions deteriorated rapidly. Flight 2904 became a worldwide case study in aviation safety schools and airline training programs, because it demonstrated a terrifying reality. Even when everyone follows procedures, accidents can still happen if the overall situation changes faster than crews can adapt. The frightening thing about Lufthansa Flight 2904 is how normal everything seemed at first. It was just another short European flight, a modern airplane, experienced pilots, standard procedures, a routine landing, and yet within seconds, everything fell apart. Not because of one giant mistake, but because small factors quietly stacked together. Heavy rain, tailwind, extra speed, hydroplaning, automation delays, and 9 lost seconds. 9 seconds that changed dozens of lives forever. Today, Flight 2904 remains one of aviation's most important reminders that technology alone can never guarantee safety. Because no matter how advanced an airplane becomes, nature, timing, and human judgment still decide whether a flight ends safely.